Hi, I'm Alex Roman.
And my name is Mariana.
We're going to be showing you guys how to use our anesthetic machine, part, and function.
Let's start off with our oxygen supply. There are two types of compressed gas cylinders. H-tanks can store a large amount of oxygen. The oxygen is kept at a very high pressurized state, up to 2,200 psi. Oxygen can be accessed from quick-release connectors throughout the designated ports and walls. E-tanks are much smaller cylinders. The E-tank can be stored under the anesthetic machine and can be attached directly to the yoke of the anesthetic machine. E-tanks come very handy in an emergency when oxygen outlets are not accessible. They can also act as a backup supply of oxygen. The tank can be opened by turning the control valve or outlet port. This control valve will be located on the top of the tank. Left is to open and right is for closed. The tank pressure gauge. The tank pressure gauge is attached to the yoke of the machine or pressure regulator of the H-tank. It lets us know how much pressure remains within the H-tank. Once opened, it will read how much pressure remains. A full tank is 2,200 psi. The anesthetic gauge must be checked prior to use. The pressure gauge must be checked to ensure that there is adequate amount of oxygen remaining in the tank. Pressure reducing valve. The pressure reducing valve reduces the pressure of the compressed gas cylinder to save operating pressures of 40 to 50 psi. The pressure is reduced regardless of how much pressure is remaining within the tank. This pressure should be checked prior to use to ensure that the pressure is within the limits of 40 to 50 psi. Line pressure gauge. The line pressure gauge reads the pressure in the line between the pressure reducing valve and the flow meter. It will read 0 when the line has been bled through the circuit or when the tank is off or empty. The flow meter. This valve is a pressure regulator. It reduces the gas further from 50 psi to 15 psi. 15 psi is the optimum pressure to safely enter the patient's lungs. It also controls the amount of oxygen delivered and enables the anesthesiast to have a rate of liters per minute. The flow meter is controlled when the valve knob is turned. The oxygen is delivered and read by what is at the center of the metal ball. The oxygen flush valve. This valve bypasses the flow meter and vaporizer. The flush valve will provide fresh oxygen to the rebreathing circuit. When pushed, oxygen flows directly to the circuit at 40 to 50 psi. Keep in mind this will also dilute the anesthetic gas in the reservoir bag. The flush valve should not be used when connected to the patient. This may damage the patient's lungs due to the high pressure of oxygen.
So to pick up where Jessica left off, the letter H is pointing to the vaporizer inlet port, and this is a point where oxygen and other carrier gases enter the vaporizer from the flow meter. And the letter I is pointing to the vaporizer outlet port, where oxygen, inhalant anesthetic, and other carrier gases exit the vaporizer, leading to the fresh gas inlet. Before I begin going over the rebreathing system's parts and its functions, I would like to remind you of its purpose, which is to deliver oxygen, anesthetic gas, and remove carbon dioxide from our patient, along with providing a method to assist or control ventilation. To begin, number 1 is pointing to the fresh gas inlet, which is where oxygen and anesthetic gases enter the breathing circuit. Number 2 and 3 are both unidirectional valves, also known as flutter valves, which keep the flow of gases in a rebreathing circuit going one way as the patient inhales and exhales. Number 2 is pointing to the inhalation unidirectional valve. This valve opens to allow fresh gas and oxygen to flow through the corresponding corrugated breathing tube and into the patient's lungs during inspiration. Number 3 is pointing to the exhalation unidirectional valve. This valve opens to allow expired gases and carbon dioxide to flow through the corresponding corrugated breathing tube, directing it to the carbon dioxide absorbent canister during expiration. Number 4 is pointing to the pressure manometer, which indicates pressure in the breathing circuit and in the patient's lungs. This pressure is influenced primarily by oxygen flow and pop-off valve adjustment. It should read 0 to 2 centimeters of water when the patient is breathing spontaneously, and read no more than 20 centimeters of water when providing manual or mechanical ventilation. Excessive pressure in the circuit can result in dyspnea, lung damage, pneumothorax, and decreased cardiac output. Number 5 is pointing to the carbon dioxide absorber canister, which contains soda lime that receives expired gases from the expiratory unidirectional valve and passively removes carbon dioxide from the expired air. The absorbent granules must be fresh to prevent the patient from rebreathing toxic levels of carbon dioxide. When saturated, the granules will no longer absorb carbon dioxide waste, and the granules will change to a violet or blue color due to the pH indicator. However, regardless of the color change, the granules should be changed after 6 to 8 hours of use, or when 1/3 to 1/2 of the granules become saturated.
So this is the famous pop-off valve. It's also known as exhaust valve, adjustable pressure limiting valve, and